So in this video, i-discuss ko yung iba't ibang conformational stabilities or yung mga ring strains, angular strains, and torsional strains associated with the different geometries of various cyclic hydrocarbons, especially cyclohexane. Okay? So mag-start muna ako dun sa mga lesser membered rings. So for example, cyclopropane. So cyclopropane is a triangular compound. Okay? So medyo rigid na ang structure niya. So hindi na natin masyadong mababago yung mga 60-degree angle na to. Okay? Which is far from the 109.5 degrees angle of the tetrahedral carbon. So meron tayong malaking angular strain. Okay? That's actually 49.5 degrees. So mataas ang angular strain niya, so hindi siya masyadong stable. Also, if you look at the Newman projection of the two carbons of this cyclopropane, nakikita nyo na eclipsed yung dalawang hydrogen o yung mga hydrogens na naka-attach dun sa mga carbons na member ng ring. So ibig sabihin, meron din siyang maximized na torsional strain. Okay? So may angular strain siya, may torsional strain siya, and dun sa last video, nakita rin natin na meron siyang mataas na ring strain. Okay? So this particular compound is very unstable. So pag pumunta na tayo sa cyclobutane, the most stable conformation of the cyclobutane is the puckered structure. So kapag puckered kasi, yung ibang angles niya ay lumalaki, nagiging more than 90 degrees. Kasi sa square na flat, 90 degrees ang angle ng lahat ng internal angles. Pero kapag naging puckered yung structure niya, ang nangyayari, nagiging parang diamond yung structure niya, nagbe-bend siya. Okay? Bumababa yung dalawang corners, tumataas yung dalawang corners. Tapos, nagiging more than 90 degrees yung angle ng dalawang opposite corners, while bumababa naman ng 90 degrees yung dalawa. So, na-discuss natin last time na meron siyang mga angles na 88 degrees lang, pero meron siyang mga angles na more than 90 degrees. So, lumalapit siya dun sa 109.5, yung dalawang opposite angles, or yung dalawang opposite corners, while yung ibang corners ay lumalayo. So, nalolocalize yung angular strain. Pero dun sa puckered na structure, or sa ganitong structure ng cyclobutane, makikita natin na nagkakaroon siya ng minimal torsional strain because of the staggered conformation kapag ka nagkaroon ka na ng puckered na structure. So, the angular strain is worsened pero nalolocalize siya. Okay? Pero the torsional strain is minimized. So, the puckered structure is the one that is favored kasi na-minimize yung ibang strains. Okay? For the cyclopentane, makikita natin na this is an envelope structure. So, imagine nyo na lang para siyang envelope. Okay? Ito yung square ng envelope, yung nalagyan. And ito yung cover. Okay? So, in this structure, makikita natin na minimize yung torsional strain due to the staggered conformation ng mga substituents ng mga hydrogens ng mga carbons na members ng ring. Also, nakita natin dun sa mga huling video na 109.5 na yung internal angles ng cyclopentane. Okay? So, angular strain is at the minimum kasi 109.5 yung angles. That torsional strain is minimized. So, wala naman tayong magagawa sa ring strain because it is a ring. Okay? To be able to minimize the ring strain, you have to cut the ring. Okay? So, hindi na natin yung issue dito. So, given that you are a ring, what can you do to the geometry or the conformation of that particular compound para ma-minimize natin yung angular and torsional strains? So, ito yung ginagawa ng mga compounds na ito. Okay? So, let's go to cyclohexane. So, for cyclohexane, meron tayong chair, boat, okay, and flat. Yung flat na structure, it's not very stable kasi mataas ang kanyang angular strain. So, ito yung may mga minimum na angular strain. So, meaning, yung boat at chair conformations, pareho silang may 109.5 degrees na internal angles. Okay? So, the angular strain is minimized. Ang difference na lang nito is yung torsional strain. So, for the chair conformation, okay, maximize yung dihedral angle at 60 degrees. So, this is a good conformation kasi minimum yung torsional strain. For the half chair, this is less than 60 degrees, although this is more than 60 degrees. Okay? Nawo-worsen yung torsional strain, pero ang nangyayari naman dyan ay nalolocalize yung torsional strain. However, this is actually worse kasi yun nga, nagkakaroon ka ng increased torsional strain sa mga iba't ibang parts. Okay? So, kasi pa-approach siya dun sa eclipsed structure. So, hindi pa rin siya ganun ka-stable. Okay? Although, hindi siya minimum dihedral angle. This is between the chair and the boat conformation, or this is between the staggered, okay, there, and the eclipsed. So, this is not as stable as the staggered conformation, pero this is more stable than the eclipsed. Okay? So, for the boat conformation, kahit minimal ang angular strain, mataas ang torsional strain. Actually, this is the maximum torsional strain for this conformation. Okay, this set of conformations. So, mas stable yung chair conformations ng cyclohexane compared sa boat. Okay? So, we will focus our discussions on the chair conformations of cyclohexane. So for the chair conformations, meron tayong dalawang types ng bonds per carbon. So ang bawat carbon dito, since this is C6H12, two hydrogens per carbon. So yung dalawang hydrogens na yan, nahati sa dalawa, yung axial and equatorial. Okay, this is only true sa chair conformations. Okay, so syempre may iba-ibang nangyayari kapag iba yung conformation. Halimbawa, boat or flat. Okay, so for the chair conformations, meron tayong equatorial and axial positions na substituents. So what are axial substituents or axial position? So ang axial position, if you draw a plane that is coincidental or that coincides with the structure of the cyclohexane, yun yung mga bonds or yun yung mga substituents na naka-perpendicular yung position sa plane. So as you can see, ito yung X, okay, itong H na to, they are pointed perpendicular to this plane. So they are called axial substituents. Okay, so axial substituent, or this is the axial hydrogen, or those substituents are in the axial position. Okay, lahat naman yan axial kasi lahat sila ay perpendicular dun sa plane. Okay, meron din tayong tinatawag na equatorial positions. So yung equatorial positions, hindi naman sila totally perpendicular, pero they lean, okay, on the plane. So yung mga equatorial, okay, sila yung mga medyo lang, okay, medyo nakatingala or medyo nakayuko dun sa with respect to the plane that is coinciding with the, or the imaginary plane that coincides with the structure of the cyclohexane chair conformation. Okay, so ano nangyayari kapag finlip mo na sila? So this is flip. So paano nag-flip ang cyclohexane? So imagine a cyclohexane being an envelope with two covers, okay, tapos opposite sides yung cover. So ganyan siya, ito yung cover number 1, ito yung cover number 2. So to be able to flip, okay, ibababa mo yung cover dun sa kabila, tapos itataas mo naman tong nasa right. So ma-flip mo na siya through that. So ganyan siya ma-flip. Okay, so this is not a very accurate representation, pero ganyan yung nangyayari. Yung nakatingala dito, siya na yung nakayuko dito. Yung nakayuko dito, yun yung nakatingala dun sa kabila. Okay, so ano nangyayari kapag nag-flip yung cyclohexane? So yung mga equatorial or yung mga axial pala, in this case axial, nagiging equatorial. Okay, so pansin nyo, this is axial, equatorial na siya. Okay, so this is axial, equatorial na siya. However, yung orientation nila, di ba may dalawa tayong orientation, yung nakatingala tsaka nakayuko. So if the axial position is pointing upwards, the equatorial position should also point upwards. Ganun din sa kapag pababa. So kapag axial ka na pababa, equatorial ka pa rin ng pababa. Okay? So ang nangyayari lang sa'yo, nagbabago lang yung position mo from axial to equatorial and vice versa. Pero kung nakapoint ka upwards, kahit mag-flip yung cyclohexane, upwards pa rin yung iyong point. O yung pag sa taas ka pa rin nakapoint. Okay? So the same is true dito sa baba. Pag tingin nyo dito, siya ay equatorial na downward, okay? Axial na siya na downward dito sa position na to. Ito naman ay equatorial na upward. Ito naman ay axial na upward. Okay? So ganun yung pag-flip ng cyclohexane. Ang nababago lang ay yung axial and equatorial orientations or positions. Pero yung orientation nun, kung pataas siya, lagi siyang pataas. Kung bababa, laging pababa. Okay? So, bago ako mag-proceed dun sa disubstituted cyclohexanes, i-focus ko muna yung discussion natin sa definition ng isomerism. So, isomerism is having the same chemical formula but differ in something else. So, yung something else na yun, it can be the connection or the connectivity of your atoms or just your orientation in space. So, kapag connectivity dun sa atoms, you are called constitutional isomers. So, an example is the C6H12. So, C6H12 can be a ring. Okay, this is cyclohexane, or an alkene. Okay, this is 1-hexene. Okay, 1-hexene, cyclohexane. Or you can be this compound called the 1,2,3,4 4-methyl-2-pentene. Okay, so magkakaiba sila ng structures, pero pare-pareho sila ng chemical formula. So, stereoisomerism naman, you have the same structure and chemical formula. Pareho kayo ng lahat except doon sa orientation nyo sa space. So, ano yung tatlong klase ng stereoisomerism? So, yung i-discuss natin mamaya is conformational isomerism. So, conformational isomerism is CisTrans Isomerism, okay, for sp3 hybridized carbons. Okay, yung mga carbons na may apat na possible connections or apat na ligands. So, another one is the configurational isomerism. Ito yung di-discuss natin in the next videos. Yung RS configuration, tsaka yung optical isomerism, which is determined experimentally, depende dun sa pagbend nila ng light. Okay? Geometric isomerism, okay, is an isomerism that occurs in rigid compounds that are sp2 hybridized. Okay? So, sa alkenes to nangyayari. So, meron din silang CisTrans Isomerism, pero this is in the sp2 hybridized regions. So, meron din tayong easy isomerism. So, i-discuss ko to next video. So, this video, okay, sa discussion natin ngayon, I'll discuss the cis and trans isomerism. So, sa cis isomer, ang ibig sabihin lang yan, parehong naka-point upward or naka-point downward yung iyong substituents, regardless kung yung isa sa kanila ay axial or yung isa sa kanila ay equatorial. This is for cyclohexanes, okay? So, disubstituted na cyclohexanes. So, trans isomer naman, kapag yung isa ay naka-point upward or downward, okay? Regardless of who points upward or downward, kung magka-opposite sila ng direction ng pinopoint, regardless kung ang position nila ay axial or equatorial, sila ay trans isomer. Okay? So, let's proceed. So, these are cis disubstituted cyclohexanes. So, pag ibig sabihin ng cis, pareho silang naka-point upward or downward. So, sa slide na to, finokus ko lang yung mga naka-point upward. Okay? So, for example, in this 1,2 disubstituted cyclohexane, okay, makikita natin na yung isa ay axial, isa ay equatorial. Hindi pwedeng pareho silang axial kasi yung axial position ng position 2 ay naka-point downward. So, that would be a trans isomer. Okay? So, pag nag-flip, okay, I'll just change the color. So, this is just pointing upward na axial, pointing upward na equatorial. Pag nag-flip yung cyclohexane, the Y becomes an axial that points upwards. This becomes an equatorial that points upwards. Okay? So, mas malinaw ang representation yan pagka nagpunta tayo sa Newman projection. So, you can see here that this is an axial position X and this is an equatorial position Y. Kapag nag-flip yung cyclohexane, ang ibig sabihin lang yan, magro-rotate to ng 60 degrees. Okay? Magro-rotate yan. Sabihin ito, itong carbon na to na square, circle, mag-rotate tong bonds na to ng 60. Okay? Tapos, bababa naman yung bonds na to. Okay? Yung bonds na to, bababa. So, magpapalit sila. Nandito na ngayon yung square. Dito na yung circle. Okay? So, nangyari sa Y, okay, pumunta siya doon. Umangat siya. Pumunta na siya dito. Axial na siya ngayon. Yung X, bumaba. Okay? Naging equatorial. Pero, both of them are still pointing upwards or naka-orient pa rin sila sa taas. Nakapataas pa rin sila pareho. So, that's still cis. Okay? So, 1,3 disubstituted cyclohexane, pansin nyo, pareho silang axial positions. And kapag nag-flip sila, pareho na silang equatorial. Hindi pwedeng isa axial, isa equatorial dahil yung isang equatorial dito ay naka-point downward. Okay? So, summarize lang natin muna. Kapag 1,2, axial, equatorial lang pwede. Dito, pwedeng axial pareho or pwedeng equatorial pareho. Okay? So, yan yung usual positioning kapag 1,3 disubstituted cyclohexane na cis ang conformer. Okay? Conformational isomer ang tawag dyan. So, makikita natin sa Newman, pareho silang axial. So, kapag inikot mo, pupunta sila dito, 60 degrees. Okay? Mapupunta dito yung dalawang substituent. So, sa 1,4 disubstituted cyclohexanes, makikita natin na yung isa axial, isa equatorial. Okay? So, kung nag-flip yung cyclohexane, makikita natin na magiging equatorial yung X, magiging axial yung Y. So, sa Newman projection, although meron tayong correction dito, okay, this should be an equatorial Y. This is just H. Okay, so dito tayo mag-focus sa Y. Okay, naka-equatorial position siya. Okay, so kapag ka nag-flip yung cyclohexane, again, mapupunta dito yung X at aangat doon yung Y. So, ito na yung bagong Y. Okay, so this is H. Correction yan. H. So, equatorial yung X, pero pareho pa rin silang naka-point upward. So, this is true kapag pointing downward naman sila pareho. Okay? This is obvious na the same goes with downward pointing orientations. So, for the next, yung mga trans naman. So, pag trans, 1,2 disubstituted, mapansin nyo na pareho silang axial or pareho silang equatorial. So, kapag finlip nyo, axial, equatorial. So, trans kasi naka-point upward yung isang axial, naka-point downward naman yung isang axial dun sa number 2 position. So, ganun din dito sa Newman projection. Okay? So, pag finlip nyo, again, mag-twist siya ng 60 degrees dito kasi bababa to. Okay? Bababa yan. Mapupunta na dito yung pupunta dito yung X. Okay? Mapupunta dito yung X. Okay? Mapupunta na dito yung Y. So, trans pa din sila. Okay? So, 60-degree rotations will result in the formation of the equatorial counterparts. Pero hindi nagbabago kung saan sila nakapoint. Okay? So, for 1,3-disubstituted cyclohexane, dapat yung isa ay axial, yung isa ay equatorial. Okay? Ganyan. Hindi pwedeng parehong axial, hindi pwedeng parehong equatorial kasi magiging cis yung kanilang conformation. So, ganun din dito pag nag-flip, isang axial, isang equatorial. As we can see here, ganun din ang nangyari. Okay? Yan. So, for 1,4-disubstituted cyclohexanes, okay, yung orientation nila, okay, yung positioning nila, parehong axial yung positions ng dalawang substituent. So, axial to. Okay? So, kapag finlip nyo yan, again, meron tayong error. This is just H. Okay? Ito yung Y na inaano natin, na kinoconsider natin. So, equatorial siya, pero pababa pa din. This is axial na pababa. Axial na pataas. This becomes equatorial, pero pataas pa rin siya. Okay? This is easily seen sa Newman projection. Axial sila pareho, pero pag nag-flip, nagiging equatorial pareho. But again, yung pointing direction nila, hindi nagbabago. Okay? So, that is for the conformational stability of disubstituted cyclohexane. So, ano kaya yung mga torsional strains that come with these particular conformations? So, sa cis isomer na 1,2-dimethyl cyclohexane, for example, makikita natin na merong isang axial at isang equatorial. Sa axial position, okay, makikita tayo ng diaxial interactions. This is 1,3 diaxial interactions. Okay, may interaction yung mga axial positions sa isa't isa. So, may energy involved yan. Okay? Etong equatorial, hindi siya nag-interact dun sa mga hydrogens dun sa cyclohexane. So, walang energy na associated with that. Walang strain. Okay? However, if you look at the Newman projection, may gauge interaction yung dalawang methyl group. Okay? So, yung dalawang methyl group na yan, ang ginagawa nila, okay, or ang orientation nila ay cis, okay? And they have this 1,2 gauge interaction na torsional strain din, okay, for staggered conformations. So may strain ang mga cis conformers, lalo na kapag 1,2. Okay? Kapag naman trans 1,2, makikita natin na axial position pareho to, okay? So nagkakaroon siya ng diaxial interactions. Otherwise mag-flip to. Dapat pag nag-flip to, okay? Pag nag-flip yan, magiging equatorial na yung dalawang methyl groups. So the most stable conformer for this 1,2 na trans isomer is the orientation wherein dalawa silang equatorial. Kasi kung dalawang equatorial, minimal yung interaction ng dalawang methyl group. Okay? So, ganyan yung nangyayari. So, kapag ka 1,3 diaxial interaction, okay, may experience yon ng mga hydrogens, okay, na nandito sa axial position. So, paano to pag nag-flip? Paano siya pag nag-flip? So, pag nag-flip yan, okay, mapupunta dito yung methyl group, mapupunta dito yung methyl group. So, magkakaroon ka naman ng gauge interaction kapag nag-flip yung methyl groups. Okay? Kasi, maglalapit yung dalawang methyl groups. Bababa yung diaxial angles nila. From 180, this is 180 degrees eh. Magiging 60 degrees na lang yung ano nila, yung dihedral angle. So, magkakaroon ka ng gauge interaction. Okay? So, mapupunta dito, tsaka dito yung mga CH3. So, that's gauge interaction. Okay? Dito naman sa 1,3-dimethyl cyclohexane, yung cis niya, meron tayong diaxial interactions, but this diaxial interactions has more torsional strain kasi dalawang axial na nasa same side yung methyl groups. Okay? So, this causes more torsional strain than this one. Okay? Yung nandito sa cis isomer na 1,2 substituted. So, kapag 1,3 na parehong axial, magkakaroon ka ng diaxial interaction. So, you need to flip this, okay, para maging equatorial pareho. So, pag naging equatorial na pareho, mangyayari dyan, mapupunta yung iyong methyl group sa dito. Okay? CH3. Mapupunta dito yung methyl group mo kapag nag-flip. Kasi pag nag-flip yan, mag-iwalay yan. Yung dalawang yan. So, for 1,3-dimethyl cyclohexane, the more stable conformer is the one in which pareho silang equatorial. Okay? So, kung pareho silang equatorial, walang interaction whatsoever sa 1,3. Okay? So, kapag trans naman, nakita natin may diaxial interaction pa rin. Okay? Yan, diaxial interaction to. Okay? So, ito nasa ilalim, hindi siya diaxial interaction actually. Okay? Wala siyang interaction kasi this is at an equatorial position. Okay? So, kahit anong flip mo dyan, yung isa sa kanila magiging axial, yung isa magiging equatorial. Okay? So, isang 1,3 diaxial interaction na event lang yung makikita mo. So, this 1,3 diaxial interaction happens in 2 hydrogens. So, actually, dalawang interactions yan per event. So, or per conformation. Okay? So, kahit anong flip ang gawin mo, magiging axial yung isa, kahit maging equatorial yung isa. So, walang magbabago dun sa torsional strain ng 1,3-dimethyl cyclohexane. Okay? So, again, balik tayo dito sa 1,3-dimethyl cyclohexane na cis. Okay? Ang more stable conformation nila is when your 1 and 3 substituents are in the equatorial position. Okay? Dito, hindi naman nagbabago kahit i-flip mo. Dito naman sa trans isomer na 1,2 substituted, ang mas stable ay yung yung equatorial. Okay? Kahit may gauge interaction yung equatorial, the gauge interaction is still has still the less energy kumpara mo dun sa diaxial interactions kasi dalawang diaxial interactions to. Yun ay isang gauge interaction lang, although that's for 2 methyl groups. Okay? So, usually, in some cases, mas nagiging stable yung axial positions kapag masyado na talagang malaki yung inyong substituents. Pero sa case ng methyl groups, maliit pa rin kasi ang methyl groups. So, medyo mas maliit pa yung energy ng gauge interaction. So, kapag dumating sa malalaking compounds, like if this is bromine or iodine, ayun, mas stable na yung conformation na to, wherein there are both axial. Okay? Dito naman sa cis isomer na 1,2, okay, wala tayo masyadong magagawa kasi kapag nag-flip tayo, magpapalit lang din yung kung sino yung axial at equatorial. Okay? So, that's the same gauge interaction. However, kapag magkaiba na itong substituents, that's another topic or another issue. Okay? So, that's for conformational stability of the disubstituted cyclohexanes and their torsional strains or the torsional strains that come with their conformations. Okay? So, in summary, ito yung mga definition natin. Okay? So, you just study them in the slides. And for the next video, I will have some examples. Tapos, titingnan natin kung ano yung may mga more stable conformations. So, mag-draw tayo ng more stable and least stable conformations ng bawat examples ng mga disubstituted cyclohexanes. Okay? So, see you next video.